Hi, everyone. Thank you for joining us. Today, we welcome you once more to Encontro Ciência. This talk will be recorded, so I ask anyone who does not want to appear to keep the video turned off. The video will later be available on CE3C YouTube channel. We are quite pleased to have today with us Joana Parente to present her work. Thank you, Joana, for being able to and available to share with us. We are also quite pleased to have with us Professor Rui Perdigão, who will present Joana, and who I now give the floor. I would just like to advise you that you can ask the questions during the talk through the chat, or at the end you can ask Joana directly. Thank you.
Hello, everyone. It's very nice to be here, and we're extremely pleased to have Joana Parente, a recent member of CE3C, a very talented young researcher who received a doctorate in physical sciences from the University of Trás-os-Montes and Alto, Douro in 2019. And she's also an environmental engineer, so she allies the best of environmental sciences with the physical sciences in general and in an interdisciplinary manner. She's currently working as a researcher in the project FRISCO, managing fire-induced risks of water quality contamination. So at the interface between the fire sciences, hydrological sciences, eco-hydrology. So it's extremely relevant, cross-cutting across CE3C. And developing the work at the Climate Change Impacts Adaptation and Modelling Group, CCIAM. But of course, with an interaction that will be very relevant to all of you at CE3C and beyond. So stay tuned. Her research main focus is in risk assessment in these environmental cross-cutting sectors. Currently, her main focus is analyzing natural hazard impacts on soil erosion and water quality. And this project in particular provides such as it articulates the land atmosphere interactions, the fire system dynamics, and the water quality issues that stem downstream of such problems, and also the entire decision support process that entails this problematic and that emerges from this will be of relevance to breathe this information from such project. So we welcome then Joana Parente. The floor is yours. Thank you so much for accepting the invitation. We are very, very honored to have you here. The floor is yours. Thank you. Go on.
Good morning, everyone. I hope everyone is okay. Thank you, Patricia and Rui, for the invitation. And now I will start with my presentation. Share. What are you seeing? You are seeing the presentation mode.
Yeah.
Okay. So I will start with this quote: fire, water, and society are inexorably connected. Why I'm starting with this quote? Because I hope that this presentation about the fire drivers and impacts and the characterization of stratal fire risk and post-fire erosion risk will be an example of this connection. So who I am, I thank you, Rui, for the presentation, but I will do another short one. I have made my high school in arts in Coimbra, but always focused on mathematics and physics. I have a master in environmental engineer with specialization in technology and environment management by University of Coimbra, and a Ph.D. of physical science of University of Trás-os-Montes and Alto. Since I finished my master's, I was a fellow researcher at UTAD and at the University of Aveiro. Currently, I'm a postdoc at F-Ciências in the FRISCO project, and I'm part of the AGU Natural Hazards blog editors team. My research areas of interest are mainly the risk assessment, especially of natural hazards, the impact of natural hazards on landscapes, and the global hydrological and water resources issues. If you want to know more, a little bit more, you can access my LinkedIn and Google Scholar through the QR code that you can find at the right corner of this slide. So let's start with my presentation. My presentation will comprise 7 points that will represent my stay at UTAD, at the University of Aveiro, and currently at FRISCO. I will start with ROUGHTS and fires, fires causes and drivers, heat waves and fires, droughts and fires, modeling the stratal fire, auto modeling stratal fire risk, and modeling the post-fire erosion risk, and what I'm doing, and I will finish with what I'm doing in the FRISCO project. So, rural-urban interface and wildfires. This problematic have raised our paper that you can access through the QR code that are in the middle of this slide. This paper had as main objectives the definition of rural interface as forest and agricultural area in Portugal, and the assessment of land use cover changes that occur in Portugal and their impact on this interface evolution. At your right, you have our framework that we implement in ArcGIS, in the environment of ArcGIS. We explain how we have access this interface. We have done a buffer of 1 kilometer from the artificial surface and intersect with the forest, with the classes of forest semi-natural areas and heterogeneous agricultural areas, and we have obtained this rural urban interface. Our main results tell us that this interface has increased during our study periods about 70%, and that in spite of the burn area in all Portugal had increased in 35%, the burn area within this interface has doubled. So, which is not very surprising that we see scenarios like this. For example, this one, it was in 2016 of wildfire at Funchal. We have another examples, for example, in the United States and in 2020 in Greece. So let's proceed with the fire causes and drivers. In Portugal, fire causes can be classified according with 4 major classes: negligent fires, intentional fires, natural fires, and identified fires. If we analyze the temporal distribution of these wildfires, we see that we have more unknown fires than the other causes. But this tendency is decreasing during the last years, and it's also possible to observe that negligent wildfires in terms of number is about the number of negligent wildfires is about 2/3 of natural wildfires, and about the double of intentional wildfires. So this problematic has arisen our paper about spatial distribution characterization of negligent and intentional fires in Portugal. You can access our paper through the QR code that are in the middle of this slide. And this paper had as main objectives the characterization of spatial distribution of negligent and intentional wildfires, the characterization of influence of human and landscape drivers on incidence of this type of wildfires, and the characterization of regional difference in spatial distribution and the role of the drivers in study. The drivers that we study were the distance to the nearest road, population density, land use, land cover, slope, and altitude. Our main results tell us that that international wildfires tend to start in medium to high population density regions, class of lower distance to roads and altitude, medium to higher slope regions in the south, and low to medium slope regions in the north. And they tend to occur in agriculture areas, forest, and semi-natural areas. The map on your right tells us the spatial distribution of this type of wildfires, namely the intentional. And it's possible to observe that the north region, in terms of number, the relative number and relative burn area, were the most affected region. Algarve, in terms of number, was the less affected by this type of wildfires, and Alentejo, in terms of burn area, was the less affected by these wildfires. According also with our main results, negligent wildfires tend to start in lowest and highest population density regions, class of lowest distance to roads in south and highest distance to roads in central and north, and regions of higher altitude, class of low slope, and at artificial surfaces. Once again, we have a map of spatial distribution, but on this case of negligent wildfires at your right, and where it's possible to observe that this type of wildfires tend to start at the north in terms of relative number and relative burn area. And that's the area of less that was less affected in terms of number was Alentejo, and in terms of burn area, it was the region of Lisbon. So let's proceed with the problematic of heat waves and fires. This has arisen our paper that you can access through the QR code that are in the middle of the slide. This paper has as main objectives the characterization and analysis of the evolution of heat waves over Portugal in present and future climatic scenarios, and assess the role of heat waves on fire occurrence. Our main result shows us that 130 heat waves, we had 130 heat waves during our study period, and that they were mainly concentrated between May and October. And that 97% of total number of fires were active during an heat wave, 83% of fires occurred during and in the area affected by heat waves, and heat waves should increase in number, duration, amplitude more significantly for the worst scenario and for the 30-year period near the end of the 21st century. On your right, you have the case of heat waves for the heat waves for 2003, 2004, and 2005. And you can see one of the reasons why we had the fires in 2003 in Central Region and Mochique. On 2004, you can see also another one of the reasons why we have the wildfire of Tavira, and one of the reasons why we have the wildfires of 2005 in Central Region. So let's, now we are going to talk droughts and fires. This problematic arises our paper that you can access through the QR code in the middle of the slide. And this paper has as main objectives the characterization of the drought regime in continental Portugal, the assessment of the role of drought on occurrence of fire, and compare the different drought indices. The drought indices that were characterized, that were assessed during this paper were two meteorological, two agriculture, but these two last were only used to see the reliability of the results of the other two of the meteorological indices. Our main results tell us that 67% of the study period were drought month. All fires occurred during drought assessed with SPI or SPI. The relationship between drought and fire incidence is statistically significant for 3-month SPI, 3 and 6-month SPI, and is particularly strong for moderate and severe drought. 85% and 87% of fire occur in an area affected by drought assessed with SPI or SPI respectively. Once again, you can see the maps on your right are our results according with SPI of 3 months. And once again, you can see one of the reasons why we had the fires of 2003 in Central Region and in Monchique, and another reason of why we had the wildfires of October of 2017 in the Central Region, Leiria and Tocha. For curiosity, it's possible to observe that in spite of the intensity of the heat waves were similarly. Of course, we have a more intensity drought in 2017, but the duration and severity on these 2 years were a little different. These results are according with SPI of 6 months, because as I told you, the 6-month SPI were more statistically significant than 3-month SPI. And it's possible to observe one of the reasons also according with this drought index why we had the wildfires of 2017 and why we had the wildfires of 2003. So now talking about fire risk modeling, this has arise our paper of total fire risk that you can access through the QR code in the middle of this slide. This paper had as main objective the mapping of the total fire risk in visited areas of Portugal using a deterministic approach based on the concept of fire risk currently accepted by the scientific community. This concept comprises the relationship between fire hazard and potential economic damage. The potential economic damage comprises the economic value and vulnerability of the elements, and fire hazard comprises the relation between fire probability and susceptibility. This last one comprises also the land use and land cover and slope variability scores. Our main results were a fire risk map that identifies the areas more prone to be affected by wildfires in the future and provides an estimate of the economic damage of the fire. For curiosity, I put here the wildfire of Góis and Pedrógão, and you can see a precondition that was red, that was in a red class. So my stay at the University of Aveiro had let me contribute for the past fire erosion risk modeling. You can access our paper through the QR code that are in the middle of this slide. And this paper had as main objective the production of post-fire soil erosion risk map for the forest and shrubland areas in mainland Portugal and assess its reliability. The framework are in your right. As you can see, we had as a calibration phase and a computation phase. The calibration phase was based in the field values that were obtained from field camps that were performed before I arrived at the city of Aveiro. Then we had computer phases that takes also several times. So our main result was successfully a map of post-fire soil erosion risk in Portugal, with identification of the areas with higher post-fire erosion risk for past and future climate extremes. Once again, I take the liberty to put here the wildfire of 2017 of Góis and Pedrógão, and as you can see, these wildfires also were in red zone in a post-fire condition. So it's not really surprising to have the news that you had from Ancião and Góis that had to interrupt their water supplies. And also, maybe this is more surprising than the others, but they had, in Góis, they found 1/2 ton of fish dead in the river. And they also suffer and decrease on tourism in Góis. And since Góis had to interrupt their water supply, they had to go to another municipality to ask to buy water to their population. So this is another news about the 1/2 ton fish that was found dead in Serra River. So I embrace with pleasure the position on FRISCO project, which has as goal to get an operational post-fire risk assessment tool and a handbook on risk mitigation measures. So for that, we have ongoing tasks that are the assessing emergency mitigation of options at landscape scale by our master student, Beatriz. Define what is a contamination episode for water treatment, identify the occurrence in historical water quality data by our master student, Niels, and develop methods to quickly map contaminant mobilization and transport from burn areas to water bodies and apply them to a historical data set by me. If you want to know more about the other two tasks that are being performed by our master students, I can put you in contact with them. To perform my task, I'm computing the index of connectivity in the watershed of Águeda. Watershed of Águeda is one of FRISCO study areas, and why I'm using this watershed, mainly because our former student, master student, Dante, had performed with another type of model, the same kind, I can say the same kind of computation, but with another model. They take more time, about 3 months to do it, and takes a lot of input, calibration, and also calculations. So our goal is to use a tool that will be more easy to use by our stakeholders, easy and quick than the lapsus model. So for that, I'm using the Selenium Connected. This application only needs the digital terrain model and the land use with C factor of EROSION models. This input takes also into account the fire severity. You can use also a target shape file, but since I already have a test at least for Agda watershed using the rivers, the outlets, and not even using one, and we realized that the better one for now is not using a target shapefile and only use the digital terrain model. So our main the results for now is you can see here the example of 1985, and you see the spatial distribution according of lapses and according with the index of connectivity, and you see a similarity spatial distribution of both approaches. If you have a close-up in burn areas, because these areas are the burn area of 1985. So if you have a close-up of burn areas, you see similarly on spatial distribution also, 1985. And I've already performed this computation for another years. And for example, here for 2005, we see on burn areas the same spatial similarity on spatial distribution, also for 2016. So to conclude, and the message to take home, the rural-urban interface increased about 70%, burnt area decreased about 35%, burnt area within this interface increased 100%. The leading drivers of number of intentional and negligent wildfires are distance to roads, population density, and altitude. The leading drivers of burn area of intentional and negligent wildfires are altitude, distance to roads, slopes, and population density. 97% of total number of fires were active during a heat wave. The vast majority of the fires occur during drought assessed with SPI or SPI. The relationship between the occurrence of drought and fire is statistically significant for 3 months SPI, 3 and 6 months SPI. And lastly, the lapse takes about 3 months to be done. The index of connectivity takes less than 12 hours. Lapse needs more information than the index of connectivity. Lapse and its index of connectivity relation depends on the target, year, and position of the fire, or even of the fire itself. Lapse and IC lead to the identification of potential source of ash and post-fire contaminants. So thank you for being here, and thanks for listening me. I'm available now for questions and discussion of our work.
Thank you so much, Joana. So now I'm just changing here for the other mode. So thank you, great presentation. And now we have time for questions and discussions. So I don't know who wants to start. If there are any questions. Just waiting for it.
Oh, don't be shy.
Yeah. Sometimes the first is the worst.
I have a question. Yes.
Yes.
Yes. Thank
Great.
you, Joana, for your presentation. Very interesting. So many publications. Congratulations. Wow. I have a question regarding the model that you built at the end. You said I don't know, maybe my question is a silly question, but I would like to know a little more about that model. Is it based on machine learning model?
What model? I didn't
The
understand.
lapsus.
Lapsus, I didn't have done the lapsus. Lapsus was our former master and was performed before I arrived. But so for that, I really don't know. Sorry.
Or maybe you can talk a little more about your model, the model that you developed.
Now, I performed the index of connectivity that you can use the already application that is already done in is a free delivery from the website. If you want me to, I can give you. And there is also an ArcGIS tool that you can also freely put on the ArcGIS. And beside that, you need to also, you need to also to install Todim tools. If you want, I can give you the information, the website for that. If you want, you give me your email, I will send you later. If you want.
Okay. I was interested by the structure, how you build it, but yes, if you said you didn't build it.
No, because our main goal is to deliver to stakeholders an already tool for them to use because they don't have our experience to use this kind of tools. So they need to be, I can say, user-friendly. So, yeah.
Okay. I sent you my email. Thank you very much.
Thank you.
Thank you, Noeline. So, any other questions to Joana? Can wait a bit, but if there are no questions, I don't know if anyone wants. Well, the presentation will be available, as I said, in the YouTube channel. If you want to go there and check something that you want to know more, or about the QR codes that Joana put in the presentation, to read the papers, you are available. They are available, and you can check that through the presentation. So, yes.
But if you want, as we have a little bit of time, Joana, if you would like to share a couple of words about. So I think that the prior question.
You are muted.
Mute.
Sorry. Yes.
Okay. I was muted. Okay.
Because someone was.
Now it's pertaining. So this kind of models, in also supporting the question that was asked before. So this does not entail machine learning. So machine learning is not part of the structure of. So these models have a basis. So the team also works with machine learning. There are machine learning models for this, and there are machine learning approaches, artificial intelligence, deep learning, and also so there are other approaches for other purposes, for other projects. But here, these models have a core, so that is essentially a combination of process understanding. So when you have process based with physical principles, so they are not unsupervised modeling. So meaning, because machine learning pure per se would entail you throw in the data, and then the architecture of the model would be agnostic in terms of the model structure. So it would just look into connections based on the available data, and then it would infer the connectivity between the processes on the basis of the data alone. And this would entail machine learning. However, so it would be inverse modeling or machine learning, in which from the data you learn the connections, and then they are then used to propagate the structure of the model. In this case, these are models that are made bottom up. So you create, so the models are created by, on the basis of physical principles about how the flows are governed, about how the different parts of the system interact. So based on physical principles, also there are always statistical components to it, because as everything in physical sciences that is based on on first principles, you have learned the first principles on the basis of empirical analysis over the years. So even the laws of Newton are empirical in their nature. So in that regard, you have a combination of empirical and process-based understanding. And then these models are built over the years and improved and then used, as Joana in this case uses and improves upon these models for these intended applications. But in this regard, and you will see, as Joana said, that you are going to see the papers, but the fundamental science behind is process-based science rather than machine learning AI based. This being said, if you are also interested in machine learning and AI and deep learning approaches, so pure data-based to learn and infer connections, you can also contact the CCIAM group, and then we can also talk about that in that regard. But it's just to clarify that there is, the modeling is not purely inverse modeling, it's forward modeling. So the same way that, for instance, the weather is forecast. So forward modeling with equations that govern the dynamics to then produce the simulated outcomes that come out of it. And the geospatial analysis is essentially geoinformation science. So in which you have these connections. So I hope that this little kind of clarification about the generic science is helpful to you.
Thank you. Thank you very much.
And Joana, of course, Joana as the one who actually works in this specific fire water issue, if you would like to add more on this, please go ahead. We have
no, you have said everything. Thank you. Everything. Thank you. Yeah.
Okay. So maybe there are no more questions. I don't think so. So thank you once more, Joana. Oh, is that no? Thank you once more, Joana. Great presentation and great work. So looking forward to read the papers that you mentioned and to see in more detail your work. So next week we will not have Encontro Ciência, but we'll return from 2 weeks now. So stay attached to these meetings and to these weekly meetings. And nice to see you all. Thank you very much, and see you next time. Thank you.
See you.
Congratulations, and thank you.
Thank you. Bye-bye.
Bye.
Bye.